Hi, welcome to TechCrunch, a place where we learn and earn technical skills in the most efficient way. Let's make coding fun. Algorithm and implementation, Heap Sort. Today we are going to present you a live demonstration and implementation of heap sorting algorithm using arrays in Java. So here, before we get into the demonstration, let's first see what is actually heap sorting algorithm. In computer science engineering, heap sort is one of the kind of the sorting algorithm in data structure, which is a comparison based sorting algorithm. And that can be thought of as an improvised version of selection sort. We have seen the selection sort in the previous session where we actually just divide and select and then sort. So in this kind of sorting algorithm, we are going to create a heap of an unsorted list or array, and then sorted array is created by repeatedly removing the largest and smallest element from the heap and inserting into the array. So basically what we are doing the same what we did in the selection. We just divide and put it in a heap and then insert it into the array where it is supposed to be located. So as you can see here in the image, what is happening here? We are dividing the entire data and then we compare from the heap. We first create a heap and then we simply compare and swap. So this is how the heap is reconstructed after each removal. So what is happening? Once you create a heap, it is going to be iterated and repeatedly again until it is not at the right position. So in the simple words, if you see, the heap sort algorithm is basically divided into two basic parts. First, we create a heap of the unsorted list array, and the second, we are having a sorted array is created by repeatedly removing the largest and smallest element from the heap and then insert it into the array. To understand it better, we'll see some examples and you can see based on that. We have a list of elements which is in an integer form, number type, and we are going to put it in a structure where it is in an array, or you can put it into the tree structure. There are two ways you can represent and perform the heap sorting algorithm. So here in this session, we are going to use array. To understand it, you can take a look at the tree form. The same way it is going to be implemented. You have to have first root element and then that will create a heap. And from that heap, that standard element will be compared to other elements and sorted out accordingly. So you can see we have a root element, any number of the array is like 45. Now first is compared with this and then it's swap. And this is how it is iterating and recursively called again and again and comparing and putting in a proper position and creating a tree structure. Similarly, we'll do it for the array. We are going to have a list of elements in an array and we find out a heap, and once we have the heap, we compare every element from that heap and swap it accordingly. Let's take a look the algorithm, how it works. So suppose we have two types of order we need to have for sorting. One is for the ascending and another is for descending. So for ascending, as we are going to increase the value of element, we need to find out a max heap element from the given input array. Once you find the maximum heap array, max heap element, you need to extract the root. It will be the maximum value in array and replace it with the last element in the array. Heapify the root of the element. Heapify the root of the element means what we are going to do, we are going to compare and then swap and repeat the steps second and third till entire array is sorted. So all you need to find out the maximum element and make it as in a heap and then compare it with the root element, and if it is larger or if you are doing for ascending and you need to make sure the other elements are lower or lesser values, and then if it is not, then we can swap it. So this is how we can do the ascending order for heap sorting. Now similarly, all you need to change is making it minimum heap. So for descending order, all you need to create a minimum heap, min heap from the given input array, extract the root. It will be the minimum value of the array and replace it with the last element in the array. Heapify the root of the heap and repeat the steps and going to be same like that. Now, when it comes to the complexity of this type of algorithm is completely depend on the length of the array or the elements in the tree structure. As you all know, heap sorting algorithm can be done in two types of data structure. One is array and another is tree. So when it comes to any type of data structure, if you have number of elements, based on that you can mention your time complexity. The larger the elements, the larger the numbers in a heap or array, the complexity based on that will go O n logarithmic n, where n is the number of elements in the structure, in the data structure. So still, if it is complicated to understand, all you need to understand is when we have the best case where when you create a heap, if half of it is already sorted, then your processing of sorting the rest of the element, rest of the sorted array, unsorted array is going to be reduced. So that will be the best case. Now, if in case your number of elements are large, you create a heap, you have a half of it, out of which half of it is already sorted, the rest of it will be based on that you can have your complexity. The complexity, the best case and the worst case and the average case is different in these kinds of sorting algorithm. So all you need to understand what type of element, what type of application you are going to apply this type of sorting algorithm is completely depend on the number of elements, the number of data you have in your data structure. Now let's take a look at the demonstration. As we know, the heap sorting algorithm depends on two types of data structure. One is array and another is tree. Here we are going to implement it based on the array. In this type of sorting algorithm, all you need to first divide and have a heap, do the heapify and then sort it. Since the selection sort was just divide and select, there is one more step we have to make sure we are going to do it here in heap. That's how it is. The improvised version of selection is what? Heapify. Heapify means when we have two subarrays of an array where one is the sorted and another is unsorted, to make the unsorted one to process it, we need to heapify it. What you need to do, find out the root element, find out the main element and then compare it and then swap it and find out the largest or smallest. So this is how I am going to implement. So just to let you know, these type of algorithm can be implemented in number of ways. You can use other data structures. In Java, you can use collection framework for array list, map. But here I wanted to make it little simple, so I'm using arrays. So let's take a look at the demonstration. So this is my Eclipse IDE. I'm going to create a Java project and the Java project name is sorting algorithm demo. And this Java project has a package and the package name is my app. Okay, I'm going to create together my app and my class name is going to be heap sorting demo. And I need the main method, of course. So it is creating my package and my class. Inside the main class, I am going to have two methods. So let's start the implementation of heap sorting using arrays, and the heap sorting algorithm divided into two methods. First, we are going to have the heapify and then we are going to have the sorting. We call heapify method in the sort method, and that sort method is going to sorting the array, and that we'll call in the main method. So let's first call the sort. First create the sort method. A typical sorting algorithm is going to implement it in this type of method where we are going to have the argument of array. We cannot have the keyword, so let's make it simple definition, simple name, AR, array. Now, in this method, I am going to have my first size of an array. What I'm going to have it in my, okay, this is supposed to be AR. Now n contains the length of the size of an array, and now I am going to have my loop which is going to run half of the array because I'm going to divide this. So for division, I'm going to have my and read it backward, scanning the array backward. And here I'm going to call process my heapify. So for that, I'm just going to leave the space, and or you can have your method called here heapify method or heap instead of it. Just to make it simple or to understand it better, you can have a heapify where I'm going to have my arguments array and the size of an array and the initial value to start with. Now once this method is called here, next step what we need to do is we need to sort and swap if it is needed. So here again I'm going to have my integer and divide it or read it the rest of my array and read it backward. And here I'm going to have my another temporary variable which is going to sort with your initial value, the first value. Since it is already divided, so that's why the first index element of my array is going to swap and need to check with this temporary variable. Now once this is done, all we need to call our heapify method, and that has gone be used like this. So what I'm doing here, I'm calling heapify method, and we need to create the heapify method, of course. I am going to have it simply like this, and we need to make it as a public. It's nothing like a private definition here. So void heapify method. Now inside the heapify, first we need to find out the largest because we are going to do for ascending order. So let's first find out the largest element, and then we are going to have our largest initialized value which is going to read it your element by odd ways and to traverse the left side of the array. So when if you take an example of a tree, we have the left side and the right side. So for the left side, to traverse it left of the tree, we need to go with the odd numbers and the even numbers. Based on that, we are taking the logic and I plus 2. So this will make for even. And for the right side, so this will be L is for left, I can mention it as a left, and this is your right traversing of your array. So left is lower, smaller than your size of an array, and array goes your till left side, and that will be your greater than your largest, the biggest number. So this will be your logic to compare it and assign it for your largest to equals to left. See, and once this is done, next similarly you need to do it for your right side. So right is smaller than n, and your right index of the array is greater than the biggest one, the largest number of the array. So if the condition is true, this will make your, okay, this is not done. Okay, if this is true, so next step what we need to do is your swapping and assign your largest to your right. You see? So once this is done, if not, largest is not equals to left or I, your first index of your array, then do the swap. This is your swapping process. AR, your indexing, equals AR, your largest. Swap largest again to swap the temporary, again another variable. Swap. Swap will help you to replace the and provide the correct position of your element in the list for ascending order or descending order. You see? So this will help you to provide the correct position of your element in the sorting form. Now once this is done, next we need to print the array. So let's have the print or display method. And display method will have your argument is array declaration, and here we need first to find your length. Once the length is done, for loop we need to read it from 0 to your size of the array, just like we used to do. And for printing, all you need to call your system out method AR indexing plus sysout and main method. Now let's come to the main method and we call these methods inside it. So for main method, first we need to have your array declaration. You can make it dynamic. For now I'm just making it simple. So let's have array definition and declaration. There are so many ways you can do your declaration. I'm just having 1 minute, just making it 20 random, 86, 43, 12. 12 is already done, 14. So not needed to any specific size, some random, 87, 23, 34. So this is my array. And let's have the size of the array first, length, and next we need to have the class object creation and the constructor. And here let's just have some label, unsorted array and /n, just for the formal presentation. In let's call the display method, where this will just simply display your array which is unsorted. Now we'll call the sort method. So for calling the sort method, all we need to have the object of the class and call the sort method. That's it. This will sort the array. Now array contains the sorted elements. So for that we need to just have a small presentation again, where we'll see and say mention it sorted array and /n, just to make it more structured and organized, and display method again. So now if you execute this, first this will display your unsorted array and then it will print your sorted array. Since it's a Java class, we need to have a Java console to show you the output. So sorted and unsorted is here. To have a better presentation, what I mixed it here is your ln. We don't need this. So you can see unsorted arrays, the one which we mentioned here statically, And in sorted, it goes like 12, 14, 20, 21, 23. This is sorted. Now how it works, it first divide this array into two and then have a heap, find out the largest element, your 87, and then 87 is the heap element. Now it is compared with the first. 12 is the right position, so it's skipped, no swapping needed. Now 21, it is needed to swap, so it goes back to the first position of the another sorted subarray. And this is how it processed. Find out the right position, find out the right element and put it in the right position according to the sorted algorithm. This is the live demonstration and implementation of heap sorting algorithm using arrays in Java. Now, important facts. If you talk about the heap sort algorithm, this works by visualizing the element of the array as a special kind of complete binary tree called heap. So we have seen heap sorting algorithm can be presented in two types of data structure, tree and array. So when we put the elements of the array in the binary form, that goes in a heap. So that's called the complete binary tree. Heap sort algorithm requires knowledge of two types of data structures, arrays and trees. Heapify uses recursion, that's called iteration of all the process. It can be difficult to grasp. So what happens sometimes when we create a recursion? That will be more complicated. To make it simple, we just process the loop. So recursion, what will happen, we call it again on its own. But to put the right condition, it is sometimes difficult to handle. So it will create some exception. But if you see the logic behind this algorithm, we are actually doing the iteration, which is calling it by itself, because it's comparing and swapping until the element is not in the right position. Heap sort has this O n logarithmic n time complexity for all the cases, if it is a best case, average case or worst case. So we have discussed about the complexity. What will happen? The process timing to sort when n number of elements in the array or tree structure exist, because it need to compare individual elements. So that's why the complexity for all the cases is the same. There's not any difference and not making any changes in their efficiency. It's not going to change. Systems concerned with security in embedded systems such as Linux kernel uses heap sort because of the ON algorithm n upper bound on heap sort's running time and constant O of n upper bound on its auxiliary storage. So what is happening in short, if we see the systems where we include the security in embedded system, that's the place we use the heap sorting algorithm, because of their complexity is more efficient at that time, at that particular process. So this is all about the heap sorting algorithm. Thank you so much for watching this video. Please subscribe to our channel and stay tuned for more upcoming interesting informative session. For any kind of assistance, questions and source codes needed, please contact techcrunch2019@gmail.com. Let's make coding fun. Thank you.